Hello. So I'm Mark Pellegrino. I'm the should I wait a minute? I'll wait a minute. Don't wait. No, okay. Um, I know it was an exciting panel. I want to talk about it too, but again, I'm Mark Pellegrino. I'm the Digitization Services Librarian at McMaster University. I've been working with digitization and digital archives for a very long time, almost embarrassingly long. I'm from an audio, video, films background mostly, but I'm new to the world of working with rare books and a lot of new textual content. And as I was learning, I decided that obviously my department should make everything we digitize fully accessible and available to everyone. But I was surprised to realize that it's actually very difficult to do so without what I'm going to call tremendous manual labor. So that's when I started exploring AI solutions. The presentation obviously has a sensationalist title, which I think is part of what got me here. Something more accurate would be AI isn't solving problems instead, it is helping. Basically, the correct tooling for using AI applications and accessibility workflows just isn't there yet, meaning that despite great advances in text and image recognition technology, our systems for creating accessible digital archives are relatively unchanged. So, jumping ahead. So, a lot of what we're talking about right now is PDFs. Why PDFs? Because it's the best tool we have for responding to an accessibility request from a student right now. It's an excellent way to encapsulate and disseminate information, and most importantly, it supports the accessibility features that we want. A PDF in some ways operates more like a self-contained website than an image format, in that it does have an internal HTML structure, and you can embed hyperlinks, images, fonts, audiovisual content, whatever you need. So some of the accessible elements in a PDF that we need are, again, the HTML tagging, where every element is assigned a suitable HTML tag, and there's opportunities there for semantic HTML5 tagging. There's a reading order, so everything that all the tagged elements have to be assigned a numerical reading order so that assistive devices know how to traverse a document in the correct order. There's, of course, the textual overlay, often the OCR. This can be born digital or OCR, and AI for OCR is mostly what we're going to talk about coming up. There's the alt text. This is another opportunity for AI. My accessibility office at McMaster has been experimenting with generating alt text, but then you're doing it externally, and you have to bring it back in and embed it within your PDFs. It doesn't connect directly. So in this image here, I don't know if you can see it very well, but that's Acrobat, which is the main tool you're using for creating PDFs. And really, it's the best tool overall for working with accessibility standards. It's auto-generated some HTML tags, and you can see it's just decided that everything on that page to the right is a paragraph. So it could have used an H1 tag for the title and H2 for the author, then some paragraph tags, and then at the bottom, there's a footnote. You could have used a cite tag, just something more semantic and descriptive for users. And then I don't know if you can see this, but like in the citation, again, there's some reading order, and it's just a mess. It just decided to put a bunch of numbers in there. So a screen reader would not know at all what to do with that. Um, the impetus for the following was receiving an accessibility request to make a work from our archives accessible to a visually impaired student. It's the Monstorum Historia by Aldro Vandi from 1642. It's 1,000 pages long. It's basically your worst case scenario for optical character recognition. It's got images, adornments. It's hand-drawn blackface font or black type font, not blackface, obviously. But it's, yeah, I knew it was going to be a challenge. So I started exploring AI options for doing the OCR, and a lot of them, like all of these tools, will generally do pretty well at looking at a digitized photo and telling you what it says. Some of them are more useful than others and have specific applications. Like Textract is really designed for like commercial applications, and Google Vision is really designed for embedding inside your web projects. But the clear winner here is Tesseract. It really incorporates well into OCR editing and accessibility workflows. The others really just generate extracted text, as in a text file that you can take away and do whatever you want with. But Tesseract will actually create a PDF from your source image with a text overlay. And it also supports external training data, which is very important. It's open source, widely supported. It can run locally, so it has a lot of advantages over the others. So this is Abby for anyone. I don't know if anyone's used Abby out there. I imagine many of you have. Yeah. So this is common in accessibility workflows. It is an OCR editor. We have 3 student staff whose whole job is just to correct OCR, and that's just in my department. The accessibility office has another 9 students doing this. So you can see the original image on the left and the generated OCR on the right. Abby does its own recognition. On the left, you can see recognition areas where you define something as green as text or red as an image, and this helps guides the OCR process to prevent errors and overlap. The right side window operates just like Microsoft Word, where you can manually correct the OCR results compared to the source image. So it's a great tool overall, but the quality of Abby's recognition just isn't at the level of something like a ChatGPT. You also can't import external training data like you can with Tesseract, so you're just kind of stuck with what it can do. It also doesn't support any accessibility features. So like any tagging, alt text, whatever, you have to do your OCR here, export it, reopen it in Acrobat, and then do that process separately. So Abby has, it does have a built-in kind of machine learning pattern training module. So you can see there's the dreaded long S or tall S there from Latin. And you can, I don't know if you can see it, but Abby is trying to tell me that's obviously an F, and then I'm going to say, no, it's an S. So I'll type in S, I'll hit train. It puts in the character map. And ideally, that's going to help recognition in the future, but this kind of training, it's more of an art than a science. You can overtrain, you can undertrain, and just showing that image to Abby isn't necessarily going to make it perform really well. So here's using Tesseract. It's just a command line tool, Linux command line tool, easy to install with a package manager. You have to download training data for each language you want to use. People freely distribute their training data online. I found excellent training data for Antique Latin at a website called latinocr.org, and another university had already done this work, which is great. The training data is just a single file you drop in a folder, and then here I'm just using a -L flag with lat to tell it to use Latin instead of the default English. So here I'm directing Tesseract to our source image. I created 3 files. One is extracted text in a text file, a PDF containing the source image overlaid with the extracted text, and an HOCR file, which we'll look at in a second. Tesseract is the only AI tool that I found that can create fully featured PDFs. ChatGPT can't do it at present. I've tried. And overall, Tesseract is awesome. It's fast. It will recognize that whole book in seconds, but there's issues, obviously, is why we're talking today. So there's our PDF we just made with the selected text, and there's the extracted text right beside it. Just open in just a simple text editor. And you can see at the top, it just, within that kind of adornment at the top of the title, it just found a bunch of random characters and it just put them in there. So in an ideal world, I could just delete those and slap them back into the PDF and we could just move along, but it's not quite that easy. So here's a closer look at the output. So this is, it obviously struggled with the images that I highlighted in red. It just made up some jumbled characters. It does 2 important things very right. Like you can see, it doesn't have recognition areas that Abby supports, so we can't tell it that that's an image, and that's why we're ending up with all those characters mixed in with our text. So it does a few things very right. So if you can see the word physica towards the top, it actually used the tall S and used the Latin tall S character. That's part of the training data. And I haven't been able to find anything else that's doing that at present. And it also used ligatures, like you can see beside it, Monstorum, it used the ST. There's a few examples down towards the bottom right there. You use the AE conjoined ligature. So it's an advanced tool, and got advantages. If you're really trying to recreate certain languages, you need to use the special characters, and a lot of tools just aren't there yet. So here's a look at our OCR, HOCR, which is HTML OCR. It's a critical part of making accessible PDFs. It allows for selecting or searching of text. It's the coordinate information that is embedded in the file. It's an HTML, XHTML document where each word is given an ID and basically just X and Y coordinates. And this is what places the recognized word over the source image. So here you can see the characters for nature exist over top of the picture of the word nature. That's how you can highlight things in PDFs. So this is where I hit a wall with Tesseract. PDFs usually have an internal font file, a TTF font, that helps text overlay better match the source image. So you can imagine if you have Times New Roman, it may not overlap on top of, like, Helvetica correctly. So it's important that even invisible text match the source. However, Tesseract uses something called a glyphless font, as in it's invisible. And I don't fully understand how that works, but ultimately PDFs made with Tesseract cannot be edited with Acrobat or imported into Abby or anything else. They just are how they are. When you try to edit the OCR in Acrobat, that's what you get. It's just blacked out. It doesn't know how to read the file at all. And same thing, Abby will just crash if you even try. So, and I reached out on Google Groups and the Tesseract GitHub, and in short, embedding regular fonts is not a feature that's coming. There's sources for this at the end of my slides if you're interested in looking at those kind of chats, what the developers said about it. But, you've got the extracted text, which is accurate and easy to clean up. So why not just go back to Abby and copy and paste it in? But it doesn't work like that. Abby and Acrobat have no system for importing external text. They both generate their own OCR and expect you to work with that. So if you simply select their OCR text and copy and paste your own external text, you're going to break all that HOCR information all that coordinate information that was generated. So you end up with very sloppy, like usable coordinate information. So I'm looking for Humanus here, and you can see it's highlighted some arbitrary part of the document because now we have no HCR, so it doesn't line up. It's just some block of text. So there's other tools, there's homegrown solutions that people are working on to solve these kind of problems. Internet Archive has made some tools available and some documentation about working with Tesseract and HOCR. People have tried to invent all kinds of systems I don't really get into. There's a lot of them. Many are not supported anymore. This is the best tool I found. It's called Scribe OCR. It's just a web-based free tool. It lets you import an image and the HOCR file together, and then you can directly edit the HOCR over top of the source image. So if you can see, there's a bunch of characters in the drop cap there. I can just highlight them with my mouse and hit delete and then export as a new document. And while that's great, it doesn't support those special characters that I mentioned. You're only doing, small jobs with this, and it's a great tool, but it would be hard to use this at any kind of scale, especially when you're working with 12 students. And I think we got 1,400 accessibility requests last year. So what do you do now? Traditional OCR editing is slow and laborious. PDFs generated with AI can't be verified, corrected, or opened in Acrobat to add additional accessibility features. So we're kind of stuck with the manual approach. Instead of creating everything as fully accessible to begin with, we're taking in accessibility requests from students and then making them wait for results. And in speaking with my own accessibility office, the way to handle that is to focus on meeting the specific needs of each student rather than to try to reach some ideal of universal accessibility. Like almost everyone will require the OCR, but not necessarily the semantic tagging or the reading order or other accessibility options. So not a lot of development is going on here, not that I can see. Small pockets of librarians and developers are working on systems, but it's slow and challenging. This is sort of reliant on Adobe, Tesseract, Abby to start working together or to expand or for something new to come along, but there's no telling if that's going to happen. We obviously are limited to PDFs. It's a great tool for working with accessibility, but Many users will interact with content through our digital archive websites. The Internet Archive Book Reader now has a built-in screen reader and multiple viewing options. My institution uses Islandora, like many of yours, and that makes it up to you to develop and implement those supports yourself. So we may start seeing more and more web-based solutions to replace PDFs, which are probably more mindfully built with semantic HTML from the beginning. On the right there is the Adobe Accessibility Checker, which is a great tool, but it's meeting all those checks is tough. So, I'm speculating here, but what I think is going to happen is that researchers and students are just going to start DIYing it, just doing it with themselves. If you just go to ChatGPT and you take that page of Latin or whatever you have and you put it in the chat, it'll return a summary, it'll return the transcript if you want it. It's all quite very accurate. So that being said, my accessibility services department that says like annually our requests are just going up. So I would like to think this is what's going to happen in the future, but I don't really have evidence of it. We're still supporting a lot of accessibility requests. So yeah, so the image on the right there is just me drag and dropping that source image I showed you at the beginning into there, and it gives you a full summary within seconds. So this obviously doesn't mean that we're just going to give up on accessibility practices, but it's going to take time. And I think the future of accessibility support is not necessarily in solving the problems I brought up today, but relying on new solutions to take shape. Okay, thanks very much, everybody. That's it for me.
Thank you. Any questions?
There's a couple there.
I have more of like a PSA slash call for aid. But I'm working right now with the AAAF community on creating guides for how web annotations through AAAF can lay over top of your digitized images and provide HTML markup versions of your digitized objects for display directly on the web page. With web annotations, they provide an accessibility property within that annotation, which maps to the accessibility features property. That's part of lots of accessibility standards. So what you can do is do things like structural navigation, alt text, all sorts of things, and give people who require accessible experiences the same experience as other users on your website. So anyways, the goal through this is to develop some plugins for Mirador to make that an option so that they don't have to ask you for a PDF version, and to provide tooling to make these annotations for our digitization staff, essentially. So if anyone uses AAAF and Mirador in their library, please join the Slack. Talk to me. My name is Brittany Lapierre, and yeah, we're very interested in creating cookbooks for people to understand how to use web annotations for accessibility purposes.
Great. Yeah, I think you're right that the PDF's gonna not be the answer for much longer, right? There is web-based accessibility. It's improving greatly, but even that though, it's still like quite laborious to create these systems. I'm looking to fully automate, and I thought kind of in the world, it's like that structure exists in the PDF world already. So I thought maybe AI can make that happen, but no, I think it's going to be completely web-based solutions soon. Yeah.
I think AI will probably be part of the pipeline for transforming the information into AAAF, most likely, which is just HTML. So, yeah.
Great, thanks.
Any more questions? Yes. Thank you. As someone who was in charge of my university's accessible formats in the library as well, I would not have to want to redo that, and you've already done the work. Did you share it with ACE or any of the repositories? I think that's one of the issues. You do so much work, you translated, like you fixed up the Latin, and now it's just at McMaster.
Yeah, well, I think I'm new enough to McMaster. This all just happened. And I've just started more recently kind of working with the accessibility workflows at my university. But no, I'll definitely reach out. My background is mostly working in digitization, and I'm just starting to expand out. I mean, in the world, I come from AV film, and in that world, there's so much copyright regulation. You're not throwing stuff up online anyway. So now that I'm interacting with web interfaces more, I'm realizing how difficult it really is to implement any of this in any form. But yeah, ACE is a good idea. Thanks.
We still have time for questions. Is any more? Any more questions?
So did you end up sending a 1,000-page PDF to the student, or how did that?
Oh yeah, I kind of left out the story element of it. So I had a student who was, we did both, right? We did, someone was in Abby just trying to get pages done, and you're delivering to the student as you go. But realistically, hand correcting Latin, you can only get a few pages a day done, right? And then I was able to whip it up in Tesseract in minutes and send that along. But then there's issues of using a screen reader with something generated with Tesseract. The reading order is not right. It has no tags. It's not really going to work unless you're directing it right to those paragraph sections. So we did both in the end. We did both, and we kind of got by with enough that we need what we needed. But it took so long doing it that I think it's questionable how useful we were to this student. But now we know, right? It was a learning opportunity.